session, where we are glad here to present our work about systematic review automation driven by Wikidata. This work is a joint work done by Data Engineering and Semantics Research Unit, the University of Sfax Tunisia, with the collaboration of Sisonke Bibliothèque community, which is a biomedical machine learning community in Africa. I will just begin by some brief introductions. So the University of Sfax is located in Tunisia in North Africa, 270 kilometers from Tunis, the capital. It is a major university in Tunisia. It is among the best universities in Africa in computer science research. The Data Engineering and Semantics Research Unit has been recently created as a part of the University of Sfax. It deals with various aspects of computer science, including Wikimedia projects as resources for driving real application at a low cost. And its members have issued several publications in highly referred scholarly journals, particularly related to these Wikimedia applications. The Sisonke Bibliothèque is a recently created research community aiming at machine learning applications in Africa. It is hosted in South Africa and has members across the continent. So it follows the Masakhana community governance model, and it is currently working on a bibliometric study and the systematic review on machine learning and healthcare in Africa. And that's why we are working on tools about automating systematic reviews. So let's begin with a definition of systematic reviews. Okay, a systematic review is simply a paper that quantifies the scholarly research output about the topic. It characterizes the findings of this research output, and it provides evidence-based recommendation and guidance based on these findings. Okay, there are many guidance across the web about developing systematic reviews. The one of the LSR community, Living Systematic Review community, the Prisma, which is the mostly used guidance for systematic reviews and meta-analysis, but there are many others as well. Okay, so the principle of doing a systematic review is simple. We are searching the database. We are getting results about the query. We are refining and screening the records we find automatically and then manually to see if they are relevant or not. And then we analyze the output of these papers to get the results. So it is long and time-consuming work that should be automated to advance scholarly research. Okay, here we think that Wikidata as a large-scale resource can be useful for such a purpose. Okay, Wikidata is a large-scale semantics database. It represents many fields. It integrates many resources and many types of knowledge. It is aligned to other database mainly in the context of the linked open data cloud, and it is freely available and reusable because it is under the CC0 license. Data is as a knowledge graph is a fully structured resource when concepts are represented as items and described by statements in the form of triples. Okay, it is consequently easy to enrich and process using a variety of tools and methods for the user interface, Wikidata integrator, Wikibase integrator, quick statements. It is easy to validate thanks to property statements, entity schemas, comparisons with external databases, logical constraints, and it is easy to query and to download using a variety of tools. It provides larger scale information for driving computer applications in multiple natural languages. So as you see, Wikidata is flexible as a resource. So how we thought of using it for systematic review creation? So there are useful applications of Wikidata for systematic review automation. And we have found 4 main ones. The first one is formulating an efficient search query to retrieve research publication from the parsed bibliographic database. The second is eliminating odd records from the initially retrieved publications using citation analysis. The third is adding further evidences to the list of verified publication based on citation analysis. And fourth is retrieving the features that should be extracted from scholarly publication to study the finding of research output about the topic. Okay, Wikidata involves many information. Okay, there are the citation data, there are the semantic relations, there are the label in multiple languages. So we are using all of them to get these tasks automated. Okay, let's begin with the first task. The first task is formulating an efficient search query to retrieve research publication from the parsed bibliographic database. In fact, we get the main keywords that are generated by users for the query, for getting the Wikidata item corresponding to an external identifier. Then we identify the Wikidata item. Okay, so then we identify the Wikidata items that corresponds to the main keywords. Then we augment the query using Sparkle queries. As you see here, we get the aspects of the keyword, we get the subclasses of the keyword, we get the parts of the keywords, and using logical operators, we get the final query. And by that, you will get, for example, not machine learning only, but machine learning with or neural network or convolutional neural networks or LSTM or ANN, etc., etc. So all the work that are related to machine learning are put together into the query. And by that, instead of having the query with machine learning only, we have all the types and subclasses and subtypes of machine learning involved there to get a final query with better results and better coverage of the output about the topic. Okay, concerning the second task, it eliminates the odd records from the initially retrieved publication using citation analysis. The principle is simple. We just go through the references of the publications, and we see if this publication is cited by another publication from the set, or is cited by another publication from the dataset. And if it is not cited, nor cited by another evidence, so it can be there is a high probability that this publication is not related to the topic and can be eliminated then. Okay, the task 3 is about adding further evidences to the list of identified publications based on citation analysis. In fact, we get the verified publication, and thanks to snowballing, we get the references and the citing papers of these verified publications. And then if the augmented papers or the added references are cited by two or cites two verified publications, and if that's true, it is added to the list of considered publications for the systematic review. Of course, for that, we are currently using Open Citation the data. However, now as we got the acceptance of the Open Citation bot for our bot that bus imports Open Citation data into Wikidata, we believe that this can be automated, and we can implement this using Wikidata as a resource. Okay, concerning the last task, it is retrieving the features that are extracted to study the finding of the research output about the topic. Well, if you attended the scientific greeting in this morning, I have explained that we can use Spacey alongside Wikidata to get topics about textual resource. So this is an application, a real life application of this. So we are getting the abstracts of the considered publication and using Spacey, and there are plenty of pre-trained models there. We are using the NCore Web SM. We are identifying the known phrase, and then we are pre-processing it. We are singularizing noun phrases and eliminating stop words. And using Wikidata Hub, the service that I explained earlier, and that allows to get the Wikidata items based on their noun or based on their external identifiers. We can get the Wikidata identifier for the noun phrases, and then we are assigning it to their parent classes thanks to instance of a subclass of relations. And then we get class-based clustering of the words that are included in the study. For example, you will get machine learning techniques that are included, and you will get a set of them that are included in the abstracts. You will get something like, for example, how it is evaluated. You can get the measures that are used. For example, Gini, rock Gini, rock, F measure, accuracy, precision, recall. So you will get them into a raster. So like that, you will get the feature, the main characteristics that you should consider when writing the systematic review. Okay, so all these tasks have been implemented at Python and are currently available at GitHub in this link. So you can find the current development status of the project at Loom. And there you will find a video with a demo about the repository we have developed. Okay, so we have tried to prove its efficiency, the efficiency of our work, by trying to apply it to a real case. Okay, the real case here is machine learning and anesthesiology. So we are using the task 1 to augment the query. And so when we have done that, we have got 7.3 seconds to formulate the query, and using the Wikidata enhanced query, but 3 seconds only for the human to formulate it, because it is 2 words only. So there are 4 seconds of difference only, and you will get a query with many words that is more exhaustive. The runtime is there is 1 second of runtime between the two. It is true that the Wikidata enhanced query will take more time to work, and it is too long. It will be 30 terms. There will be 30 terms in the query. But when we run it, we get a decent number of results. So when we run the user-generated query, we get 87 records. But however, we get 74,000 records when we run the same query, but when augmenting it using Wikidata terms. So this is rather explained by the fact that the ICU and the machine learning terms have been added to Wikidata thanks to the query augmentation based on Wikidata relations. Okay, so that's all for what I have to share. These are the image credits for what I have done. These are the references for the work, and you can contact me to ask about anything. And thank you. Time for question now.
Thank you very much. Very, very interesting. I will take up a question marked in the other pad. What's the next step for your work?
Okay. Okay. The next step for my work is that we will try to refine the code, because the code is quite messy now. We'll try to refine the code, let it more practical to reuse. Second, we will try to investigate its efficiency and optimize it. And third, we are looking forward to get more people into the project, because it is a project that can be relevant for wide evidence there. And that's why we are inviting people to join the Sisonke Biotech initiative there. So that's why I'm here, actually. And the Loom video can explain you what are the main challenges that we are facing in details. So we are having them, we are visualizing them with video, with examples about the problem we are having. So anyone can jump in, can see the video, and can get all what we need and can contribute, actually, the
Great.
project.
Thank you very much. Thanks for your answer. If you could, after the session, check on the other pad, there is one more question on a link that's missing. And then I say thank you. And
Thank you.
welcome the next people after.